T, and today's topic will be the soil. And remember, we're going according to the CSEC biology syllabus. Let's get straight into the video. So what is soil? So soil is something that we see around us, but not many of us actually know what forms soil. So soil is actually formed from rock by chemical and physical weathering. Weathering is simply just the breaking down of the rock. Now, the particles are actually slowly colonized by small plants like mosses and ferns. And as these plants die, they add humus, and other larger plants and animals can then move in. So we're going to talk about a major component of soil, which is known as inorganic rock particles. Now, we already said that soil is formed from the breakdown of rocks in a process called weathering. We can actually classify the rock particles by size. Now, these particles form the skeleton, and just like in the human body, that the skeleton provides support for the human body, the skeleton provides support and firm anchorage for the plant roots. They also provide shelter for soil animals such as the earthworm and provide a surface for attachment of the soil microorganisms. So we already said that we can classify the rock particles based on size. Gravel is actually the largest, usually greater than 2 millimeters, and clay is the smallest, less than 0.002 millimeters, and in between that we have silt and then sand. So we're going to look at some other components of soil. Let's start first by looking at mineral salts. They actually come from humus and they're dissolved from surrounding rocks. They become mineral ions when dissolved in the soil water. These salts are essential for plant growth. The next component is air. Air is actually present in the spaces between the soil particles. The larger the soil particles, the larger the air spaces. And this is depicted over here. You can see that these larger particles actually have larger air spaces associated with them versus these smaller soil particles. It's very hard to make out the air spaces because they're so tiny. So oxygen in air is used for respiration and for aerobic humus. Nitrogen in the air is used for the nitrogen fixing bacteria to form nitrates. So the rainfall actually causes water to enter into the soil and form a thin film around the soil particles by capillarity, which is simply just the attraction of the water molecules to each other and the water molecules to the soil particles. The smaller the soil particles is actually the larger the surface area and the more water that is held. So if a soil has smaller soil particles, then it is likely to hold more water. Why do we need water in the soil? Well, the soil uses the water for photosynthesis and in dissolving the mineral salts which we spoke about. It also prevents drying of certain organisms that live within the soil. This actually explains how the water can behave in the soil. So if you have capillary water, the water is actually available for plant roots to absorb. The more water that is in the soil, it can become gravitational water, where the soil is so saturated with water it begins to drain out of the root zone. On the other side, you can have hygroscopic water, where the water is basically so minimal that it adheres strongly to the soil particles. It is at this point that plants can begin to wilt due to severe dehydration. Soil organisms include roots. It also has bacteria, fungi, worms, insects, burrowing animals, plants, and roots. So soil organisms actually have important functions in the soil. Earthworms, for example, improve aeration and drainage by burrowing, improve fertility by adding humus through excretion of waste and decomposition when they die. They also grind the soil particles and bring leached minerals to the upper layers of the soil. Saprophytic bacteria and fungi actually decompose organic matter to form humus. Plant roots prevent erosion by binding soil particles. And remember, soil erosion is basically the washing away of the top layer of the soil by water, plants, animal, air, snow, or even human. Other components of soil include humus, which is formed from dead and decayed organic matter. It's mainly in the topsoil, as you can see in this diagram. It adds mineral salts to the soil, binds the soil particles together into soil crumbs, and absorbs and retains water and mineral salts. Insulates the soil from extreme temperatures, and it prevents erosion by binding soil particles. So remember, a soil with good crumb structure has a good drainage system. It's well aerated, it's workable, and this is due to it having fairly large air spaces between the crumbs. So it's important to note that soil differs in its texture and characteristics, and soil texture can determine water availability and permeability. Land use and management. These are all influenced by soil texture. So we're going to be comparing clay and sandy soils. Now, when we're comparing, the particle size is actually what can give us a hint to the different properties and what to expect. So once you understand the principle of how particle size affects aeration, water holding capacity, and drainage, it's easy for you to assess other soils. So clay soil, for example, is small in the particle size, and the sandy soil has large particle sizes. And we said already, the smaller the particle size the smaller the air spaces. So when we're looking at aeration, we expect a poor aeration in clay soil because it has smaller air spaces between the particles. Sandy soil has good aeration because of the large air spaces. When we're looking at water holding capacity, the smaller the space is the larger amount of water can be held by capillarity due to the closeness. So the particles are able to adhere even stronger to the water because of a small space. So because we know that clay soil has a small airspace, we can understand why it has good water holding capacity. The soil is able to remain wet due to the small spaces and the larger amount of water being held by capillarity. The opposite is for sandy soil. It's pretty poor in its water holding capacity and it dries out pretty easily, and that's because it has large spaces. Drainage. So drainage in clay soil is pretty poor. And if we think about a strainer in the kitchen, and we think of a strainer with a larger space, larger air spaces, that is going to drain the water from your food quickly, versus a strainer with smaller air spaces is going to take a longer while. So the drainage in clay is pretty poor because of the smaller air spaces. So it gets easily waterlogged, meaning water gets trapped easily in it, versus sandy soil. The sandy soil is good in its drainage because it's not easily waterlogged due to its larger spaces. So you can see that it's pretty much the opposite. The water holding capacity is good in clay soil, but its drainage of the water is poor. That makes a lot of sense, right? Now, when we're looking at mineral iron content, it's pretty high in clay soil. And the reason for this is the slow drainage of the water in clay soil causes the mineral ions to remain in the soil for longer. So it tends to have a higher mineral ion content. Also, the clay particles actually attracts the ions. In sandy soil, however, the mineral content is low, and this is because of the rapid drainage which we spoke about due to its larger air spaces. When we look at the ease of farming or cultivation, clay soil is pretty hard to dig and plow because it gets very sticky when wet, as you can see in the image, and it gets very hard when dry. So it's not very good for farming. Sandy soil, however, is easy to use for farming because the large particles do not stick together. It's very easy to plow and dig. Root penetration. So root penetration in clay soil is very hard because they have very sticky and small spaces. Sandy soil is easily penetrated by roots as it is not sticky and it has large spaces. So this is just an example of what we've been speaking about. So we said that the sandy soil has larger particles, larger rock particles than the clay soil. So you can see that it has larger air spaces or larger pores among the particles, which allows for rapid drainage but poor water holding capacity. And you can see the opposite. It has smaller pores in the clay soil because of smaller particles. So it tends to have very good water holding capacity but very poor drainage. So understanding how the soil particle size can affect properties of soil, we can use that information to improve on different types of soil. So we're going to look at clay soil. So adding sandy soil can actually improve aeration and drainage in clay soil. And this is because sandy soil has larger air spaces between its larger soil particles. And so it's able to drain water also more easily than in clay soil. So mixing the two together actually creates a soil mixture that has better aeration and drainage. Adding humus, which is compost, manure, or treated sewage, can cause particles to stick together or what we call flocculate. Humus actually adds mineral salts also to the soil. Adding lime makes particles flocculate into the crumbs as well. It improves aeration, drainage, workability. Adding lime actually makes acid soils less acidic. A less acidic soil will make more nutrients available to plant roots and therefore improve plant growth. And we said the lime improves soil structure. When you add lime to clay soil, the tiny clay particles will group together. They'll basically clump together and form larger particles. And as I said, this is called flocculation because it's reminded someone of a flock of sheep coming together. So we say flocculation. And when we have flocculation, it creates more air spaces so the soil can drain better. So sandy soil, adding humus can actually improve the water holding capacity of sandy soil. It also adds mineral salts just like in clay soil. There's a technique that we call mulching, where you spread a layer of dead leaves or manure on the soil. These two are actually examples of mulching. This reduces evaporation, which prevents the drying out of the sandy soil, and it adds mineral salts. So remember, we said that sandy soil has good drainage, but we don't want it to drain too rapidly and too much. So that's why we use mulching to prevent excessive drying out. So loam soil is actually a mixture of soil that is ideal for plant growing. It's a combination soil, meaning it's a combination of different types of soil, particularly clay, silt, and sand. And this gives the benefits of each with few of the disadvantages. We're just going to use right here as an example. This would be medium loam soil, where it's about 50% sand, 80% silt, which is on this side, and 20% clay. Clay loam would be about 40% clay, about 60 to 70% silt, and 50% of sand. So we're going to get into some issues that we can face with soil. So soil erosion is actually the washing or blowing away of surface layers of soil. It is caused mainly by destruction and removal of plants, by humans, for example, harvesting crops, cutting down trees, the trampling of soil, and also by animals, for example, grazing. So roots and humus bind the soil particles, and leaves prevent evaporation of soil water, and it also breaks the forces of rain. So when the plants are removed, the soil particles are no longer bound together and become dried out. Wind can also blow away surface layers, and rain can wash away deeper layers. So we're going to be looking at different ways in which we can improve and maintain the integrity of soil and also prevent soil erosion from occurring. The first way we're going to look at is reforestation, which is immediately replanting trees after removal. So it sounds very similar to deforestation, but deforestation is the removal of trees. So reforestation is replanting trees after deforestation. Now, crop rotation is basically, as the name suggests, planting a different crop on a rotational basis. So you can see in the picture, year one we had on bed number one tomato, bed number two beans, bed number three carrots, and by year two we switched it up. So after the tomatoes were finished, we planted in carrots. Bed number two had tomatoes, and bed number three now had beans. And if you notice, usually they include leguminous crops such as peas and beans because they actually increase the soil nitrates. Terracing and contour plowing. Now, planting on hillsides actually prevents erosion caused by the water moving down the hill or slope. So fertilizers are basically substances added to soil to provide mineral ions necessary for healthy plant growth. So as the name suggests, it makes the soil fertile. Now you have two different types of fertilizers, organic and inorganic. And we can compare them based on origin, cost, application, action, effect on the soil, and effect on earthworms. For organic, they originate from plants and animals. Inorganic suggests man-made, so they're made in factories and usually contain nitrogen, phosphorus, and potassium. Organic because it comes from natural beings, it's cheaper. Inorganic is expensive. The application of organic is pretty difficult because it tends to be bulky and sticky. Inorganic tends to be easy to use. So you can see that it tends to come in granules, sometimes powder forms. The action of organic is actually slow to act because you first want to decompose, and then that will allow for a longer lasting effect. So even though it's slow to act, it has a long lasting effect. While inorganics, they're quick dissolving action. So we're quick to act, but they last for a shorter period of time. Organic fertilizers improve the crumb structure and water retention. So that's the ability of the soil to hold water. That is what organic fertilizers do. But inorganic fertilizers can be harmful if used for too long. It can lead to erosion and acid formation. Now, organic fertilizers encourages earthworms to the soil, while inorganic fertilizers can actually be harmful to earthworms. So we're going to go on to irrigation. Irrigation is actually the process of artificially watering the land in dry areas or areas of non-productive soils in low rainfall, and this is done to create productive soil. So we tend to use water from rivers and dams by routes of man-made ditches and irrigation canals. So these are showing you various examples of irrigation canals and ditches. If you found this video helpful, don't forget to like it, share it with a friend, and subscribe to the channel so I can continue to make more videos for you. I'll see you in the next lesson.